For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called Skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a Skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe Skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the Skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that matched the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first because they blend into the mist, but once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right, it's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air, like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, STEVE for short. STEVE is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like STEVE could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-STEVE by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. STEVE's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve After Midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not 1, not 2, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's a reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the 2 reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Poland claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Poland and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.
So many asteroids pass through our solar system and we don't even know about it. Those are rocky pieces of material left over from the time when our solar system was forming, about 4.6 billion years ago. They move around the sun, but not in the way planets do. We're talking about true rebels that prefer to follow some pretty strange paths. Plus, they spin in different ways as they travel between planets and other space objects. And the majority of them come from the main asteroid belt that's located between Jupiter and Mars. Most stay there. But Jupiter has quite a strong gravity, so it can push some of those flying rocks in different directions, and towards us too. They're sometimes round, and sometimes they have odd shapes, with pits and holes from all that crashing into other space rocks. As we currently know, there are more than 1 million of them in the main asteroid belt, and that's all good until some of them move in our direction. NASA keeps an eye on them, so we know everything's fine, at least for now. But that wasn't always the case with our beloved home planet. If Earth could talk, it would probably share so many crazy asteroid stories. We're talking about those space rocks that left impact craters we call domes. They have a specific shape with a raised center, similar to when you throw a pebble in a pond and see some water splashing upward. But we'll never be able to learn about many others. I know this raised center sounds like something you're supposed to see right away, especially if an asteroid that once slammed into the surface was big. But we're talking about millions and millions of years of erosion, so wind, water, and even gravity do what they do best and erase traces. They wear down impact domes, and some sites even end up hidden under layers of rock and dirt, or they disappear forever because Earth's tectonic plates keep moving around. Check out the Moon. It's experienced many collisions too, but over there, there's no ocean or tectonic plates moving around, or even wind to slowly, through millions of years, erase craters from its face. Basically, its entire history is written on its surface. But Earth has its own forces that can erase such places as the Vedafort impact structure and the Chicxulub crater. You know, the famous one that wiped out the dinosaurs? Luckily, scientists have new methods to find ancient craters. They often focus on the mess impacts made, which means the materials they threw around. And the Australian continent is especially interesting since we're talking about a playground for asteroid hits. By that, I mean ancient supercontinent Gondwana that dominated the South hundreds of millions of years ago. Experts know about 38 impacts, plus they speculate about 43 more. Some structures are relatively small, while others are big and completely hidden. And recently, a scientist named Tony Yates has discovered strange underground magnetic patterns in New South Wales, Australia. Yay! New clues of a giant asteroid impact! And when I say giant, I really mean it. It's a structure 323 miles in diameter. This might be the largest impact site ever found. This spot is called the Deniliquin structure. Its magnetic patterns show characteristic ripples around the center, like when a rock hits the water. There are also fractures that go outward from the center. And it seems rocks from inside Earth ended up pushed into these fractures. That's a typical story for big asteroid impacts. This structure was probably located in eastern Gondwana hundreds of millions of years ago, way before it split into several continents, including Australia. At the moment, all we know about this crater is what we see on the surface. To find more information about this collision and get some proof, we'll have to drill into the ground. An asteroid this big is definitely not a joke. It could have caused a massive ice age and maybe even wiped out around 85% of species, even more than the asteroid that ended dinosaurs. In 4.5 billion years, which is how long our planet has existed, it's been punched by hundreds of big asteroids. But that doesn't mean every space rock that enters our atmosphere really makes it all the way to the ground. Most of those that manage to pass the atmosphere are relatively small, for instance, 3 feet across. That's good for us because any space rock that's less than 82 feet in diameter most likely won't make it past our planet's atmosphere. Since these space rocks come towards us very fast, they heat up the gases in the atmosphere, which burns them away. By the way, once cosmic intruders enter our atmosphere, they turn into meteors. And in most cases, they don't cause much damage, if any, as they fall down. But we used to have way larger things flying around and crashing into Earth. At least 190 of them have left scars you can still see today. One of the really big ones is in South Africa. It's 99 miles wide. It's actually the largest. At least that's what scientists think at the moment because they still need to check as many details as possible about this new crater in Australia. This one in South Africa formed about 2 billion years ago, and an asteroid that created it was probably larger than the one that had wiped dinosaurs away. And when an asteroid is bigger than 0.6 miles, it can have really big effects across the world. This impact was so strong that it could have caused fires everywhere and thrown lots of dust into the air. And when you have so much dust in the atmosphere, the climate on the planet can change for months or even years. Then we also have the most popular asteroid that made a giant hole we today call the Chicxulub crater. You know the story. It crashed into our planet 66 million years ago when dinosaurs were wandering around, catching food, falling in love. Basically, just doing their thing. The crash itself didn't erase them right away. It threw a lot of debris into space, and when it fell back to Earth, fires and flames were everywhere. The hit also produced a big cloud of dust that covered the planet for years. This cloud blocked the sunlight, which harmed plants and entire food chains. Even those dinosaurs that survived the crash and such difficult conditions had a hard time finding food, so they didn't make it. At least they left us many fossils and turned into the inspiration for movies and stories. A long time ago in Canada, something big crashed into our planet and left a big hole we today know as the Sudbury Basin. People used to think it was an asteroid, but now some experts think it might have been a giant comet made up of a mix of ice and rocks. The hole is almost gone now because of weather conditions though. But people still get to mine iron and nickel there, and at the same time find the leftovers of whatever space object fell there. If you move deep in southern India, you'll find a big hole called Lonar Crater. Locals stumbled upon it 200 years ago and believed it might be from a volcano. but now we know it's a trace from a meteor that crashed into the ground about 35 to 50,000 years ago. What's so special about this crater is that it's the only one known to have formed in a type of rock called basalt. Around the crater, there are hills covered in trees, and animals like peafowls and gazelles live there. Birds also like to visit the lake near the crater during the winter. And the lake itself is quite interesting too. It can turn pink because of all those tiny organisms that live there. But this color change doesn't last long.
Have you ever felt so happy that you were up on cloud 9? Well, in truth, they don't actually number these guys, but they're cool nonetheless. And I can show you super rare phenomena related to clouds. Hey, what time is it? I see Hector, so it must be 3 p.m. Who is Hector? Oh, Hector isn't a person. It's a thundercloud cluster. It forms almost every afternoon from September to March over the Tiwi Islands in northern Australia. Since Hector has this constant timing, airline pilots and boat captains have used it as a navigational guide for decades. This is a unique thunderstorm, not just because it's very punctual, but also because it's one of the world's most consistently large thunderstorms. Hector the Convector, yeah, it's sometimes referred to with an even cooler name, reaches heights of approximately 66,000 feet. What we see is vertical speed billowing white clouds. At the top of the clouds, we have an anvil or mushroom-shaped cloud, like a cherry on the top of a cake. By the way, this anvil can go up to thousands of feet high. So how is this thundercloud formed, and why does it only pop up in this specific location? Well, there are a couple of precise meteorological conditions for this. The Tiwi Islands play a big part in providing these elements. Both Bathurst Island on the west and Melville Island to the east have the perfect shape, size, and location for Hector to develop. The second reason is sea breezes, which carry moisture. They form over the islands, move from all sides, and finally meet in the middle, like the song. These converging winds need to go somewhere. They clash and then go up. Now here's the fun part. As the rising air column gets cooler with altitude, the water vapor condenses into liquid droplets and makes clouds. Sea breezes I mentioned here also happen to be tropical marine air. The tropical atmosphere is another vital element in forming Hector. This fella has an important duty related to the tropical monsoon rain. Hector is responsible for most of it. This airport on the Tiwi Islands has an average annual rainfall of around 80 inches. To put it in perspective, that's double what London or San Francisco get annually. Next, we have polar stratospheric clouds, also known as nacreous clouds or mother-of-pearl clouds. I like the third name the best. They're mostly seen in the Antarctica and Arctic regions, but they can be spotted in places like Scotland, Scandinavia, and Alaska too. This type of cloud looks like an impressionist painter touched the sky with a brush. They appear as iridescent pastel shades in the sky around sunset. Nacreous clouds can be seen best during civil twilight, meaning when the sun is between 1 and 6 degrees under the horizon. They mostly form during winter at around 49 to 82,000 feet high. Mother-of-pearl clouds can be harmful to the atmosphere. Their existence may lead to a chemical reaction that breaks down the ozone layer. Nature's other incredible wonder is morning glory cloud. It kind of looks like a giant rice ball floating in the sky. This rare phenomenon can be regularly seen in only one place in the world, the southern part of the Gulf of Carpentaria in Australia. Although morning glory can be observed in other parts of the world, you have better chances to see the morning glory cloud around September and October. This cloud bank says hello to Australians, often from only about 330 to 660 feet above the ground. It can be 620 miles long and can travel at speeds of up to 38 miles per hour. Now, if I were there, I'd record a time-lapse of this cloud. What's cool is to see one of these fluffy clouds. What's even better is to see up to 10 consecutive roll clouds. That happened before and can happen in the future too. Arcus cloud, it's another name for it, has been known since ancient times. Not just modern-day people noticed this unusual cloud formation. The local Garwa Aboriginal people gave it a special name. The Royal Australian Air Force pilots, too, reported seeing this Arcus cloud in 1942. Then various teams of scientists study this phenomenon. Okay, but how is it formed? With the right atmospheric conditions. Duh. Well, when the humidity in the area is high, it provides moisture. If we add strong sea breezes to the equation, we get the morning glory clouds. Well, what do we have here? Pyrocumulus cloud. They may form as a result of convection, started by heat from wildfires or volcanic activity. It's generated as a result of the intense heating of air near the surface, which causes convection and lifts the air mass to a stable point. Moisture present in the atmosphere and evaporated from vegetation or volcanic gases can condense on ash particles, leading to the formation of this cloud. Since it's generated by flames, it's also called flammagenitus. The next phenomenon is cloudbursts. You can think of these as giant balloons filled with water. When the balloon bursts, the water splashes. Similarly, here, cloudbursts make rapid precipitation. They depend on thunderstorms. A thunderstorm may come with strong uprushes of air. This blocks the condensing raindrops from falling to the ground. As a result, a huge amount of water may accumulate at upper levels. When the upper levels get saturated and too heavy, the accumulated water falls all at one time. Now, I wouldn't want to be around when the water dropped down. It would be like taking the world's shortest shower. Luckily, cloudbursts are most commonly seen in mountainous areas. Let me give you an example of how intense this one can get. A rainfall of nearly 2.5 inches in 3 minutes was recorded in Portobello, Panama in 1911. That is a lot of water dumped in a place all at once. Now we have a solo riding cloud. It can occur in different parts of the world. Here we see a picture taken at Bursa, Turkey. This orange-tinted saucer-like cloud amazed and kind of scared people. We can relax, it was just a lenticular cloud. Think of this one as a pancake. Here, clouds are stacked in linearly stratified layers. Normally, those layers remain separated. But if an obstacle, in this case Mount Uladog, spans several layers, the air coming from beneath is forced to go up. Why? Well, that's because air that's closer to the ground holds more moisture. The moisture layer near the surface rises up with the air. The temperatures cool with altitude, and that air parcel is chilled down to its dew point as it ascends. Voila! The air becomes saturated and makes a cloud. Now, this cloud doesn't last very long. Once the accumulated air has passed over the mountain or the obstacle, it comes down to its regular level. Poof! It warms up again and disappears. Keep in mind that wind is an important element here. In our case, this cloud formed near Mount Uladog because strong winds were coming from the south because of low pressure over northern Italy. Hey, I should be a weatherman. Rainbows are mesmerizing by themselves. What if I tell you that nature has gifted us also with rainbow scarf clouds? World Meteorological Organization says that these kinds of clouds are called pileus clouds, but that's a boring name, so I won't use it. So, the better named rainbow scarf clouds are accessory clouds. This means that they're dependent on a larger cloud system to develop. Firstly, an accessory cloud enlarges horizontally, and then a shape like a cap above the top appears. This part is attached to the upper part of another cloud. Now, these clouds don't last long, similar to a regular rainbow's time of appearance. The main cloud underneath eventually rises up and absorbs the rainbow cloud above. Farewell, you beautiful little thing, you. There are many other cloud formations that we could mention, such as fall streak hole or hole punch clouds. Do you ever see that the horizon is full of white clouds, but there's a hole to remind you of the blueness of the sky? It's like someone put their hand in there and spread the clouds. Well, as the song goes, we have just looked at clouds from both sides now. So, what are some other natural wonders that fascinate you? Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So, there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where two tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater. As well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the fifth largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the fifth largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.